Okay, so now we discuss some important results or properties of inverse Trigo functions. So here first one, that is sine inverse of minus x, that is equals to minus sine inverse x. It's similar to this result, sine of minus theta equals to minus sine theta. If you remember, this is called an odd function. So same thing true here, remember. Sine inverse of minus x equals to minus sine inverse x. Second one here, that's for cos inverse. Cos inverse of minus x, here it is pi minus cos inverse x. Remember, these are standard theorems which we are stating without proof. Now it requires proof, but we are not giving proof, we are just stating without proof. But if you cos inverse of minus x, it is pi minus cos inverse x. Third one here, that is tan inverse of minus x, which is minus tan inverse x. So here, like sign, minus sign will come out. Fourth, it is same as this for cot inverse. Cot inverse of minus x equals to pi minus cot inverse x. Fifth one here, that is cosec inverse minus x equals to minus cosec inverse x, same as sine function. And sixth one here, that is sec inverse of minus x equals to pi minus sec inverse x. So for these three functions, sine inverse, tan inverse and cosec inverse, you have directly that minus sign outside. For the other three functions, cos inverse, cot inverse and sec inverse, you have pi minus, remember. This is always true. Here if you want to write for these two functions, domain is this modulus of x is greater than or equal to 1. For these two functions, here domain is x belongs to R. You go back to last session, you will realize. And for these two functions, here domain is modulus of x is less than or equal to 1. This just for your information. That means x should be between minus 1 and 1. Here x can be any real number, and here this means x belongs to all real number other than minus 1 to 1. That is just nothing but the range of cosec and sec functions. Okay, so let me just illustrate this. You had such example in previous exercises, like suppose you want sine inverse minus 1 by 2. So now nothing you have to think, you can use this result. So this is minus sine inverse 1 by 2. You know what is sine inverse 1 by 2? It is pi by 6. So this is minus pi by 6. This is your answer. Suppose we want cos inverse minus 1 by 2. Now if your cos inverse, your pi minus. So this is as good as pi minus cos inverse 1 by 2. As per that theory. Now cos inverse 1 by 2, it is pi by 3. So this is pi minus pi by 3. So it is 2 pi by 3. Now what is precise meaning of this? If you find cos 2 pi by 3, you will get exactly minus 1 by 2. You can verify. But every time this value and this value should come in appropriate domain of sine inverse function. This should be in closed interval minus pi by 2 to pi by 2. That is important here. This value, and this value should be in the domain 0 to pi. That remember. Right? Any value will not do. That respective value should fall in that appropriate domain. Here minus pi by 2 to pi by 2, here 0 to pi. Third one, for example, I want to write sine inverse 0. So your answer is obviously 0, because you know sine 0 is 0. But remember, this also you know sine pi equals to 0. So you cannot write implies sine inverse 0 equals to pi. This is not correct. Why? Because that pi is not in the domain of sine function, that is minus pi by 2 to pi by 2. So whenever you write the values, whether these or this should be an appropriate domain. Here this 0 fall in minus pi by 2 to pi by 2. You cannot write pi here. So if I write this is wrong. Sine inverse 0 is pi. This is not correct, because sine pi is 0, but 0 pi doesn't fall in this domain. So that way you need to write the appropriate value. Suppose one more, if I write, suppose I want to write tan inverse minus 1. So it is minus tan inverse 1. Now you know tan inverse 1 is pi by 4. So this is minus pi by 4. One more, if I write, suppose if I write cot inverse minus 1. So as per that theory, this is pi minus cot inverse 1. Now what is cot inverse 1? It is pi by 4. So pi minus pi by 4. So correct answer is 3 pi by 4. And remember that 3 pi by 4 is in the domain of cot function. So what's the domain of cot function? Open interval 0 to pi. One more, if I write, suppose I want to write tan inverse of minus root 3. So it is pi minus tan inverse root 3. Now tan inverse root 3 you know that is pi by 3. So pi minus pi by 3. This is your answer. Now next result, which is about corresponding function. So suppose I have cosec inverse x, so which is equals to sine inverse 1 by x. You know that x is from r minus open interval minus 1 to 1. So this is a domain. So if you want to convert cosec into sine inverse, just to take the reciprocal of angle. Second one, if I write, for example, here sec inverse x, so which is, so sec inverse x, you can write cos inverse 1 by x. So if you want to convert sec inverse in cos inverse, just to take the reciprocal of angle, where again x is from the domain. This means r minus open interval minus 1 to 1. This is the precise meaning of this one, remember. Third one, which is important, it is about cot inverse x, which is tan inverse 1 by x. So again reciprocal of the angle, but here we have two possibilities. If x is positive, in case if x is negative here, then we have pi plus tan inverse 1 by x. I repeat, if you want to convert tan inverse, cot inverse into tan inverse, just take the reciprocal of angle. But if x is positive, you have just tan inverse 1 by x. In case if x is negative, you have pi plus and reciprocal of the angle. Sec inverse, that is cos inverse, take the reciprocal of the angle. Cosec inverse, in terms of sine inverse, take the reciprocal of the angle. Now I'll see some examples based on this. So here, for example, I want this cosec inverse 2. Now this you can rewrite like sine inverse 1 by 2. You know sine inverse 1 by 2 is nothing but pi by 6. One more, suppose we are given sec inverse 2 by root 3. So this you can write cos inverse root 3 by 2. Now cos inverse root 3 by 2, that again you know, so this is here pi by 6, you know, because cos pi by 6 is root 3 by 2. Now let me see, this is one of the question from earlier exercise. Suppose we have cot inverse root 3. Now this you can write tan inverse 1 by root 3. Here this is positive, remember. So this is nothing but pi by 6 again, you know. Now let's see one more example here. Tan inverse root 3 minus sec inverse minus 2. For example, this one. Tan inverse root 3, you know, it is pi by 3 minus, if you recall the result, this is pi minus sec inverse 2. So this is pi by 3 minus pi minus, this is as good as, if you want, this you can write cos inverse 1 by 2. So this is nothing but pi by 3. So this, if I simplify, this is nothing but the pi by 3 minus, this is 2 pi by 3. So it is just minus pi by 3. That is your answer. So now next result is about addition of sine inverse and cos inverse. Sine inverse x plus cos inverse x. Your x is, you know, from -1 to 1. Then next, tan inverse x plus cot inverse x. 1, 2, and third one, that is cosec inverse x plus sec inverse x. Here each of this is pi by 2. This pi by 2, this is pi by 2, this is pi by 2. Your domain of tan inverse and cot inverse is all real numbers, so x belongs to R. Here x belongs to R minus open interval -1 to 1. That is sometimes written as this, modulus of x is greater than or equal to 1. This is sometimes written as modulus of x is less than or equal to 1. So sine inverse plus cos inverse pi by 2, tan inverse plus cot inverse pi by 2, cosec inverse sec inverse pi by 2. For example, if I have this sine inverse, let me write 1 by 12 plus cos inverse 1 by 12, which is always pi by 2. These two values should be same every time. Second one, if I write tan inverse, for example 20, cot inverse 20, for example, so this is again pi by 2, and so on. So that's the third result. Now fourth result, this is addition property mainly. Addition property, this is about addition of two inverse Trigo functions. So we take positive values of x and y here. X and y are positive here. The first result is about tan inverse x plus tan inverse y. This is for tan functions only. That is given by this one. This is one of the standard result of trigonometric function. X plus y upon 1 minus xy. If you remember, tan alpha plus tan beta upon 1 minus tan alpha into tan beta. Here the important condition, the product of these two should be less than 1, remember. It should be less than 1. Both should be positive, but the product of these two x and y should be less than 1. Less than 1. It's a theorem, it can be proved, but proof, as you know, we are not giving. We just state it. Tan inverse x plus tan inverse y equals to tan inverse x plus y upon 1 minus xy. Now question arises, if xy is more than 1, then what? So xy is more than 1. Then same thing, but we have here pi plus, remember, pi plus tan inverse x plus y upon 1 minus xy. Here we have pi plus, remember, this expression is same if xy is more than 1, and it is quite possible that xy may be exactly 1, xy equals to 1, for example, product of these two is 1, then answer is just pi by 2. So these are the three important possibilities we have. The first one is tan inverse x plus y equals to this expression x plus y upon 1 minus xy, where xy is less than 1. If it is more than 1, then pi plus, and if it is exactly 1, then pi by 2. And here second one, that is for minus tan inverse x minus tan inverse y, that is equals to tan inverse x minus y upon 1 plus xy. Again the same result, remember. Here you minus, so here minus sign. Here you had plus, so plus sign. And here you know tan alpha minus tan beta upon 1 plus tan alpha into tan beta formulas. This works for every x, y, remember positive. We don't have like this 3 possibilities. So this is again important. These 2 results we'll use frequently. For plus we have x plus y upon 1 minus xy less than 1. Here simply this expression. More than 1, then pi plus, exactly 1, then pi by 2. For minus we have no possibility. Here minus, here opposite sign. So next is about interrelation among inverse Trigo functions. Inverse Trigo functions. That is here. First one, for example, we have sine inverse x, so we can reduce into cos inverse. That is, here angle would be root of 1 minus x square, and this is equals to, you can write in form of tan inverse also, which is x upon root of 1 minus x square. Here x should be between 0 and 1. Second one, cos inverse x, which you can write in form of sine inverse. So we have sine inverse root of 1 minus x square, and which also you can write in form of tan inverse. Here it is this upon this, which is root of 1 minus x square upon x, and x is between again 0 and 1. Now reverse. From tan inverse we reduce in sine inverse and cos inverse. So here sine inverse x upon root of 1 plus x square, and cos inverse is nothing but 1 upon root of 1 plus x square. Here x is positive. This way you can convert. Now here no need to remember these properties. You can use such right angle triangle. For example, I have sine inverse 1 by 2. You know answer is pi by 6, but I want to convert into cos inverse. So what you can do, draw a triangle here. You just imagine this as sine function. Sine, you know, it is opposite upon hypotenuse. So this will be root 4 minus 1, which is root 3. Now you want to write cos from this. So this is equals to, what is cos function? That is adjacent upon hypotenuse. So that is cos inverse root 3 by 2. And you know that these and this both are pi by 6. That way you can do. Suppose I have this sine inverse 1 by 2. Suppose I want to convert into tan inverse. So again we draw the right angle triangle. So 1 opposite upon hypotenuse. So adjacent is root 3. I want tan inverse. So tan inverse would be opposite upon adjacent. So 1 by root 3. You know that this is pi by 6. Suppose I have next one more. Third example. This was second. Suppose I have tan inverse 2, for example. I want to convert into sine. So I'll draw a right angle triangle. You know sine tan inverse 2. You can imagine 2 by 1. So this is opposite upon adjacent here. So hypotenuse would be root 5. Root 4 plus 1 by Pythagoras. Suppose I want to reduce into sine inverse. So sine inverse, you know sine is nothing but opposite upon hypotenuse. So you can write 2 by root 5. Suppose I want to write in terms of cos function. So this is cos inverse adjacent upon hypotenuse. So 1 by root 5. So that way you can convert given trigonometric function into any other trigonometric function with the help of right angle triangle. No need to memorize these results. This simply just based on this result only. One more I'll take. Suppose I want to evaluate this. Evaluate tan inverse 1 by 2 plus tan inverse 1 by 3, for example. Now if you're plus, you can use that fourth result. So I can write tan inverse here 1 by 2 plus 1 by 3 x plus y upon 1 minus x into y. Remember here x into y is 1 by 6. 1 by 2 into 1 by 3, which is less than 1. So if you simplify this here, tan inverse, this is nothing but 5 by 6, and this is 6 minus 1, so again 5 by 6. So this is just tan inverse 1, and you know tan inverse 1 is pi by 4. So the value of this expression tan inverse 1 by 2 plus tan inverse 1 by 3 is pi by 4. So now I'll go to exercise 2.2. So there I'll start with third question first. So their left hand side is tan inverse 2 by 11 plus tan inverse 7 by 24. Now it's like tan inverse x plus tan inverse y. So tan inverse, remember I've checked indirectly, 2 by 11 into 7 by 24. This is less than 1. So xy is less than 1. So 2 by 11 plus 7 by 24 upon 1 minus 2 by 11 into 7 by 24. I've used this tan inverse x plus tan inverse y equals to tan inverse x plus y upon 1 minus xy. That's what I'm using here. Now you just simplify this. So this is 48 plus 77 upon 11 into 24. This is nothing but 264 minus 14 upon 11 into 24. So this will get cancelled here. This is 125, this is 250. So this is equals to tan inverse 1 by 2, which is your right hand side. Next question, fourth question, their LHS is 2 times tan inverse 1 by 2 plus tan inverse 1 by 7. Now in such questions, what we do, here I'll write tan inverse 1 by 2 twice plus tan inverse 1 by 2. The 2 times I wrote in this way, plus tan inverse 1 by 7 as it is. Now we use this result twice. We use first for this, we keep as it is. Now here xy 1 by 2 into 1 by 2. So xy is less than 1 here. So this is equals to tan inverse 1 by 2 plus 1 by 2 upon 1 minus 1 by 2 into 1 by 2 plus tan inverse, this is as it is, 1 by 7. Let's simplify this. So this is tan inverse, this is this is 4 by 4 if I take LCM here. This is 3 by 4 plus tan inverse 1 by 7. So this is equals to tan inverse, this is 4 will get cancelled, so it is 4 by 3 plus tan inverse 1 by 7. Now again use the same result here, that is tan inverse 4 by 3 plus 1 by 7 upon 1 minus 4 by 3 into 1 by 7, and you simplify this, you will get exactly RHS. Right? So we have used the tan inverse x plus tan inverse y equals to tan inverse x plus y upon 1 minus xy. Here xy is less than 1, 2 times, one over here and the other one over here, so we'll get the right hand side. So now I'll go to first question. There you are asked to prove that 3 times sine inverse x equals to sine inverse 3x minus 4x cube, and that x is from minus 1 by 2 to 1 by 2 here. So obviously to prove this we start with RHS here, right hand side. That's easier. So sine inverse 3x 4x cube. Now inside the bracket, if you notice, this is one of the Trigo formula. 3 sine theta minus 4 sine cube theta. So we put Trigo substitution here. Put x equals to sine theta. So here sine inverse 3 sine theta minus 4 sine cube theta. Why I've placed this sine theta substitution? Because you know this is a formula of sine 3 theta. So this is equals to sine inverse, you know that this is sine 3 theta. And now you know composition of inverse and the function, this will get cancelled. So this is 3 theta. Now you recall what was the substitution? You had x equals to sine theta. So it implies what is theta from this? Sine inverse x. You get theta from this, which is sine inverse x. So 3 times sine inverse x, which is your RHS. And question number 2, second question, there you are asked to prove 3 times cos inverse x equals to cos inverse 4x cube minus 3x. Same way, start with RHS here, right hand side, and put x equals to cos theta substitution. So if you start with this is cos inverse of, you know, this is the formula of cos 3 theta. So this become cos 3 theta. Again this 2 will get cancelled. So it is just 3 theta. Now what was x here? That was cos theta. So what is theta from this? Which is cos inverse x. So it would be 3 times cos inverse x, which is LHS.